let me just share it with you. Let me know if you have you are encountering some technical glitches while watching this video. Sabihin nyo lang pagka meron kayong problema at hindi niyo ma-access, ha? Hindi niyo marinig.
Branches of mechanics, these are statics and dynamics. It is presumed that you have already taken up courses on statics, the study of bodies at rest, because in this module our focus is on dynamics, the study of bodies in motion. Kinematics falls on the category of dynamics. So, what's the difference between statics and dynamics? Let us recall, statics is concerned with the equilibrium of a body that is either at rest. Meanwhile, dynamics deals with the study of behavior of body or particle in the state of motion under the action of force system. Scientific discovery of kinematics can be traced way back the time of Galileo Galilei, who was one of the first major contributors in this field. He was the one who experimented on using pendulums and falling bodies. Meanwhile, in dynamics, the most significant contributions came from Sir Isaac Newton, who is famous in the formulated three fundamental laws of motion and the law of universal gravitational attraction. In understanding motion of a body, the frame of reference will later on aid in determining displacement of the particle or object. Displacement is the change in position of an object relative to its reference frame. Simply put, an object has moved or has been displaced. For example, if a vehicle moves from a house to a grocery store, its displacement is the relative distance of the grocery store to the reference frame, or the house. The equation of displacement states that delta x is equal to the difference between the final position and the initial position, where delta x is the displacement of the object, x is the final position, and x sub o is the initial position. Let us differentiate vector from scalar. When we say vector, according to vector algebra, we are referring to a geometric object which has a magnitude and direction and that it can be added to other vectors. The direction of a vector in one-dimensional motion is given simply by a positive sign or a negative sign. On the other hand, scalar is any quantity that has magnitude but no direction. A scalar is a simple physical quantity that is not changed by coordinate system rotations or translations. Examples of scalar are distance, speed, time, mass, temperature, pressure, kinetic energy, gravitational potential energy, work done, power, current, potential distance, and resistance. While examples of vector quantities are displacement, velocity, acceleration, force, weight, and moment. Make sure not to forget correct usage of units for scalar and vector quantities. In any engineering problems, correctness of your answer largely depends on the correct usage of units. Going on with our lesson, let us define speed and velocity. Take note that speed is a scalar quantity since it has only magnitude, while velocity is a vector quantity having both magnitude and direction. Average speed is calculated as the ratio between the total distance traveled over the total time of travel. Simply stated, Speed is equal to distance divided by time. In contrast, average velocity is defined as the change in position or displacement over the total time of interval. Velocity is delta x divided by time, where delta x is the displacement of the object, delta t is the change in time of the object. Moving on to the last topic for lesson 1, acceleration. By definition, acceleration is the rate at which the velocity of a body changes with time. It is a vector quantity with both magnitude and direction. Equation of acceleration states that acceleration is equal to delta v divided by time, where delta v is the change in velocity of the object, delta t is the change in time of the object. In 1687, Isaac Newton defined 3 laws of motion that concern the behavior of moving objects. These scientific statements help to explain the nature of matter and space. Newton's first law of motion is often called the law of inertia. His second law shows the relationship between force and acceleration. His third law is often called the action-reaction law of motion. Interestingly, Newton's laws of motion is presented in this lesson with illustrations to help you build your problem-solving skills. Take note, Newton's laws of motion can be integrated with other concepts such as forces producing accelerations, which shall be discussed in succeeding modules. Now let us tackle each law one by one. Let us start with the law of inertia, which states that an object at rest stays at rest, or an object that is moving at a constant speed in a straight line keeps moving at that speed unless another force acts on it. When traveling in a train or any other vehicle, have you noticed how you move forward when it stops? You just experienced law of inertia. It is the tendency of a body to resist the change in motion or rest. When a vehicle stops, you tend to jerk forward before coming into a complete stop. The second law, the law of acceleration, states that the amount of force needed to make an object change its speed depends on the mass of the object and the force required. An example of law of acceleration is a pitched baseball goes faster than one that is gently thrown. Lastly, the law of interaction. For every action there is an equal and opposite reaction. Force can be illustrated by a rocket. As the fuel in the rocket ignites, the force of the gas expansion and explosion pushes out the back of the rocket and pushes the rocket forward, as stated in law of interaction. Present the work in a logical and orderly manner as suggested by the following sequence of steps. 1. Read the problem carefully and try to correlate the actual physical situation with the theory you have studied. 2. State the given, tabulate the problem data. 3. Draw any necessary diagrams. 4. Identify what is required and use a consistent set of units. 5. Solve using necessary equations algebraically and completely. 6. Report the answer with no more significant figures than the accuracy of the given data.
Ma'am, excuse po. Ma'am, nawala po
Hindi niyo
yung
makita.
video po.
Wala yung
Opo.
video.
Yes po.
Okay, sige.
Kinematics is considered to be more involved in both the forces applied to a body and its motion must be taken into account. In any case, the most effective way of learning the principles of kinematics is to solve problems. To be successful at this, it is necessary to present the work in a logical and orderly manner as suggested by the following sequence of steps. 1. Read the problem carefully and try to correlate the actual physical situation with the theory you have studied. 2. State the given, tabulate the problem data. 3. Draw any necessary diagrams. 4. Identify what is required and use a consistent set of units. 5. Solve using necessary equations algebraically and completely. 6. Report the answer with no more significant figures than the accuracy of the given data.
Yes po.
Okay, sige.
An empty airplane having a mass of 40,500 kilograms and a takeoff acceleration of 2.3 meters per second squared. What is the net force accelerating the plane?
So this is for the sample problem. So according to the problem, we got an empty airplane and we need to determine the net force accelerating in the plane. So this is the computation. Okay. So medyo mabilis lang. So I am going to explain
An
the
empty airplane
problem.
has a net accelerating force of 93,150 Newton and a mass of 40,500 kilograms. What is required takeoff acceleration of the plane?
So you would notice here, you are given some problem. You are given two problems here, two sample problems. And as you notice, I have suggested in there that you're going to make use of the scientific procedure in solving any that might help you in all the engineering problem that you're going to solve later on. So you start with finding the data, what are the given data, and then you determine what's supposed to be the question in the problem. Then after that, you check on what formula you is applicable, comparing the given data and comparing the question, the one in question, so that you would know what variables are missing and what variables are given. So you would know what formula you're going to use. And then you show your solution. Make sure that your solution would have its corresponding units. So the unit is a critical contribution, has a critical contribution or factor in your solution or answer. So make sure that the unit that you are going to use or you're going to use in the computations are consistent. So make sure that the units you are using in any calculations and any computations are consistent. So if the given data is in SI unit and you are questioned or you are being asked to find values which are in English system, or it might be the other way around. You are given the English system units, but you are supposed to give your answer in SI units. You have to make sure that you are consistent with the unit that you are using in your computation. So what you can do is to convert the units from the SI to the English or English to the SI, whichever is the most appropriate solution conversion that you are going to do. But make sure the hint there is you have to make sure that you are consistent with the unit that you are using. Okay. So let me just share first to we are just checking on we're going to check whether I would be able to share it with you the best. Okay. So we're going to identify which Newton's law fits with the given statement. So if you can answer together with me, huh? So let me just check. Let me start. This is an example of the interactive activity It's just unfortunate that we still have to double check how can we run this for the online classes. But this is an example of the activities that we have here. So all you can do is to um, solve the puzzle here. Okay, so you can drag and drop the jigsaw piece on the board. So later on, I am going to share with you some more of this. Okay, some more of these activities. So probably this might be part of the.
Yes,
Yes,
ma'am.
ma'am.
Okay, so let's see if this would play. Okay, so we have here 60 minutes. So what we are going to do is, kayo yung magsasabi sa akin kung ano yung ilalagay natin dito. And then ako na lang yung lalagay dito. Drag and drop kasi ito. So you just state to me kung anong answer natin dito. An object at blank stays at blank, and an object in blank keeps moving with the same blank unless acted upon by an blank force acts on it. So let's start with the first box. We have here the answers. You tell me, and then I will be the one to do the simulation na lang. It's supposed to be the parang
Rest
remote.
po.
Rest po, ma'am.
Okay, so alin ang pipiliin natin?
Rest po.
Rest po.
Rest. Okay, so majority of you. This one, ito ba?
Yes, ma'am.
Yes po.
Let's try this one. Okay. Then, the next.
At rest po.
At rest po.
Okay. Then next,
Motion po.
Motion po.
motion.
Motion po.
Ito.
Yes, ma'am.
Okay. Next,
Direction.
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 direction. Ito, direction.
Yes po.
Yes, ma'am.
Okay. Next,
Unbalance.
Unbalance, ma'am.
Balance po.
okay. So let's see. So we have one question. Okay, so we got it. My God. Let's go to the previous question. What about the other question? Okay. So we only have one question of one. So this is the Newton's first law of motion. According to the new laws of motion, an object at rest stays at rest, and an object in motion keeps moving with the same direction unless acted upon by an unbalanced force acting on it. So that is okay. This one. You answer this. Okay, calculate the mass of an object to create a force of 3.2 kilonewton at an acceleration of 5.3 meter per second squared. You tell me, you solve first and then tell me kung alin ang aking pipindutin dito, and then we'll check if you will get your correct answer.
Calculate the mass. The first mass.
603.77, ma'am.
About the other,
603.77 grams po.
603. Majority na kayo, 603.
Yes po.
Sige. Ito natin yung 677. Hindi natin malalaman kung tama yung answer nyo unless matapos natin to, ha? Okay. So we got a correct response for this. Okay, let me continue. How about for this one? In describing the acceleration given a 2 kilogram object by a 10 Newton force acting on it, which of these units is appropriate?
MS squared po.
Mass over ano po. S squared.
Meter per second squared.
Itong meter per second squared? Ito ba ang inyong answer?
Yes,
Yes
po.
po.
Yes po.
Po.
Sige, you agreed on this, ha? Let's see. Okay, so that's right. We have a correct response here. Continue. So this one. We determine the force necessary to move a 4,000 kilogram object at an acceleration of 1.2 meter per second squared.
$4,800 Newton.
4,800 po.
800 Newton.
1,800.
4,100. Ito?
Yes
Opo.
po.
Yes po.
Okay, sige. Let's submit. Okay, so we have a correct response in this. How about for this one? So we have a force of 5 Newton producing a body with a baseball at an acceleration of 4.5 meter per second squared. We are going to determine the mass of the ball.
1.5 kilograms po.
1.1 kilogram.
1.1. Ito, 1.1.
Yes
Yes
po.
po.
Okay, so let's submit. Try natin. Okay, so we have a correct response in there. So we've got the correct response 4 out of 10. Next. We calculate the mass of an object with a net effective force of 4.5 kilonewton and an acceleration of 126 centimeters.
3,750 kilograms, ma'am.
Majority. What's the answer?
3,750 kilograms, ma'am.
3,750 kilograms po.
3,750.
3,750 kilograms. Let's submit. Oh, we've got an incorrect answer here.
5,400 po.
5,400 po.
5,400 po.
Bago tayo bumili ng isa pa, ano naging problema dito sa 3,750?
5,400.
5,400. Sige, let's see. Yung 3,750, is it correct? Let's try, sorry. But we cannot, we have chosen the 3,750 here. One, hindi na natin pwede siyang mabago. Isang beses lang pala natin ito pwedeng bago. Yun lang. Go to this one.
Hindi po yun.
Okay, so the force of gravity on the moon is 1/6 as large as on the Earth. How does free fall acceleration on the Earth compare with free fall acceleration on the Earth? Free fall acceleration will be, what's your answer? Our score here is 40 out of 100. What will be our answer here? Oh, walang problema. Ito naman, ano tayo? Anyone? Si Gracel nag-raise ng hand para sa the same. Tama ba, Gracel? The same din ang answer mo?
Po ako sure nag-base lang din po ako sa question.
Okay. So marami sa inyo ang nag-answer nung ano. Sino ang magbe-break ng tie? Tatlo yung nagsabi nung the same, tatlo yung nagsabi nung 6 times. About the others, alin ang pipiliin ko? D or C? The same or 6 times larger?
Okay, ma'am.
6 times larger.
6 times larger? Sure kayo? Sige, piliin na natin yung 6 times larger and let's see kung ano magiging answer natin. So that's correct. That is 6 times larger. Let's move on to the next question. So we are moving a dresser. It has a mass of 36 kilograms. The acceleration is 0.5 meter per second squared. Question, what is the force being applied?
18.
18 Newton.
80
po.
newtons po.
Sure kayong 18 na?
Yes, ma'am.
Sige. 18. Ito, tama itong pinili ko.
Apo,
Yes
ma'am.
po.
Sige, submit natin. Let's see. Okay, so we have a correct answer. Let's move on to question number 8. So the mass of the object has an acceleration of 3.5 meter per second squared and a net effective force of 80 kilonewton.
And 2,857.
You agreed on that? Ito ba? Ito?
Yes, ma'am.
Yes po.
Walang magkokontra.
Yes po, ma'am.
O, lahat tayo dito ang answer natin.
Yes, ma'am.
Baka naman.
Sasubmit ka na to. Okay, 22,857 kilograms. C. Oh, that's correct. So we have a correct response. We've got 70 out of 100. Move on to question number 9. So we have a car traveling 1 kilometer hill at a constant speed of 10 kilometer per hour and returned down the hill at a speed of 20 kilometer per hour. If the time needed to turn around is ignored, what was the total speed for the trip? So what is your answer? Anyone? O, ano nang answer natin? Bakit nawala na ang aking mga kausap? Yes. Wala pa din?
.3 po.
Other
Zero, ma'am.
merong isa na yung nagsabi ng 13.3. Isa rin, one said 0 kilometer per hour. How about the others? Fifteen. Zero, dalawa ng zero, isang 15, isang 13.3. How about the others? Okay. Dalawa, tatlo ng zero. How the others? Yung may, kung hindi nyo naman, pwedeng chat nyo na lang sa akin. So we have three answers. 3 answered 0. 113. Bali, apat na yung 0. 1 in 15. 0. Okay. 5 ng 0. Dalawa ang 13.3. About the others? Wala na? Yung iba, how about the others? Marami na nagsi-zero ang answer. Ano ba yan? Safe answer lang o talagang na-compute nyo? 1, 2, 3, 4, 5, 6, 7. Okay, 7 ang 0. About the others? Marami talaga nagsasabi ng 0. Okay, sige. Let's see. Okay, 0 ang answer. Marami ang nag-0. 15. Tinatanong mo ba ako, Miss Pornobe, Mr. Pornobe? Be sure.
Miss po, ma'am.
Ay, Miss Pornobe. Sure ka? Hindi pa. May question mark ka eh.
Hindi pa po.
Si Grazel, 0. Okay, sige. Marami ang nag-0. How about the others? Sige, try natin yung 0. Since marami sa inyo, dadalwa, tatlo. 13.3, merong 13.3. Pero majority 0. Sige. Answer natin yung 0, ha? Try natin submit. We did not select the correct response. So, since we cannot choose another one, so bawi na lang tayo next time. Let's go to question number 10. So, this is the last question. So, double check nyo yung answer nyo ha, kasi marami nag-answer ng 0, pero according to this, we did not select the correct response on this. So, double check your answer. About for this question number 10. So, there are two blocks pushed along a horizontal frictionless surface by a force of 20 Newton to the right. Sorry. And so just imagine yung figure. The figure that the 2 kilogram block exerts on the 3 kilogram block is what? Okay. So just imagine the figure. So there are two blocks which are being pushed along a horizontal frictionless surface. The force is 20 Newton to the right. So the question is the force that the 2 kilogram block exerts on the 3 kilogram block. Dalawang blocks ini-exert. One is 2 kilogram, the other one is 3 kilogram. Pinupush ng 20 Newton block going to the right. So you draw your illustration. So that is another tip. If you are going to solve any worded problem and you would want to make illustration, then you do your illustration before making the solution. It would be better that you know how to draw your illustration according to the given worded problem. So that if there are no illustrations or any figure given in the problem, you can use your own solution, illustration or figure. So any wild guess? Anong answer natin? Sige, 1 mentioned 10 Newton to the left. 8 Newton. Sige.
8 po, ma'am.
8. Sige, tingnan natin. Tatlo na yung nagsabi ng 8, tatlo nagsabi ng 10. Please indicate kung ano yung okay. Indicate yung direction. Make sure pati yung direction indicated. To the left. Meron nag to the right na 8 Newton. 1.
8 newtons to the left po, ma'am.
To the left. 1, 2, 3, 4 yung left. Okay. But the others? Okay, nadagdagan pa yung to the left, to the left. To the left, na 8 Newton. How about the others?
8 to the left.
8 Newton to the left. This one. Yan ba? Remember
Yes,
our,
ma'am.
okay, sige. Remember our score is 70 out of 100. So marami sa inyo nag-majority na yung 8 Newton to the left. Try the others before we submit this one. And let's see kung makiscore tayo ng may additional pa tayo. Pag mag-answer kayo, make sure kung 8 Newton yung na-determine niyo, make sure yung direction identified. To the left, 8 Newton to the left. Mukhang majority na yung nagsasabi ng to the left. Others, what about the others? Okay, so this is a wild guess. Let us check. Submit natin. Okay, so that's the correct response. 8 Newton to the left. So let us see. We passed the exam or the quiz, I mean. So at any rate, this is how the simulation, I mean the interactive multimedia module that we have. And I might let us see kung meron pa tayo ditong ibang activity. This is the other one. Let me just check. So hindi na ito kasama sa ating ano. Let me give you first lesson for the projectile. So let's go to the next lesson. I'm just checking on the whether I can share it with you na itong lesson na to. Ayaw talaga nitong mag-work.
Opo.
Okay, sige. Ito, nakikita nyo na?
Opo.
Yes, ma'am.
Statics is the analysis of bodies at rest, but we now begin the study of dynamics, the part of mechanics that deals with analysis of bodies in motion. Dynamics includes kinematics, which is the study of geometry of motion, and kinetics, which is the study of the relation existing between the forces acting on a body, the mass of the body, and the motion of the body. It's used to relate displacement, velocity, acceleration, and time, without reference to the cause of the motion. Kinetics is used to predict the motion caused by given forces or to determine the forces required to produce a given motion. The word particles used in this module does not mean that our study will be limited to small corpuscles or a small body. Instead, it indicates that the motion of bodies, possibly as large as cars, rockets, or airplanes, will be considered without regard to their size. Analysis of particle means that only the motion of the particle as an entire unit will be indirect. The linear motion of a particle, the position, velocity, and acceleration. Uniform motion. The motion is said to be in uniform motion. The bodies moving with constant speed or velocity have uniform motion or increase at the uniform rate. Not uniform motion. Equal distances are covered in equal interval of. The motion is said to be in non-uniform motion. The bodies executing non-uniform motion have varying speed or velocity. When we observe our surroundings, we can see many physical interactions taking place around us. Everything in the universe, if we observe carefully, we will find that everything in the universe is in motion. However, different objects move differently. Some objects move along a straight line, some move in a curved path, and some move in some other way. Motion can be classified as translatory, rotatory, and vibratory. In the translational motion, a body moves along a line without any rotation. How various objects the line may be straight or curved. Do they move along a straight line? Do they move along a circle? A car moving in a straight line has transnational motion. Linear motion. Straight line motion of a body is known as its. We come across many objects which, moving in a straight motion of objects such as a car moving on a straight and level road is linear motion. The spinning motion of the tire about its axis is called its rotatory motion. A top is spinning about an axis. Particles of a top spinning move in circles and thus individual particles possess circular motion. Does the top possess circular motion? In vibratory motion, the particles move to and from about a fixed point. The motion of a body about its mean position.
This is actually part of calculus, application of calculus in topic. So the topic is regarding rectilinear motion. But this, since we are talking about physics, we are now going to apply physics in other form. Let's go back to the module. No. Let me just double check it. Let me go back to the topic on the rectilinear motion.
Motion of a particle along a straight line is called rectilinear motion, linear motion or one-dimensional motion. The simplest example of accelerated motion in a straight line occurs when the acceleration is constant. To start our study of rectilinear motion with a constant acceleration, we need a frame of reference and the object to be represented as a particle. Since the motion is confined to the movement along a straight line, we take a coordinate axis along this line. For horizontal motion the x-axis is used, and for vertical motion the y-axis is sometimes used. It is therefore convenient to present the vector nature of the displacement, velocity and acceleration merely by the use of positive and negative numbers. We will take the origin of our reference frame to coincide with the initial position of the object. Consider the position P occupied by the particle at time t and the corresponding coordinate x in figure 4. Consider also the position P occupied by the particle at a later t plus t. The position coordinate of P can be obtained by adding to the coordinate x of P the small displacement x, which will be positive or negative according to whether P is to the right or to the left of P. If SI units are used, x is expressed in meters and t in seconds. The average velocity will thus be expressed in meters per second, meter/s. If US customary units are used, x is expressed in feet and t in seconds. The average velocity will then be expressed in feet per second, foot per second. Instantaneous velocity is equals to the limit of delta x divided by delta t, as delta t. Instantaneous velocity is equals to the limit of delta x divided by delta t, as delta t approaches 0. The acceleration a is represented by an algebraic number which can be positive or negative. A positive value of a indicates that the velocity increases. This may mean that the particle is moving faster in the positive direction or that it is moving more slowly in the negative direction. In both cases, delta v is positive. A negative value of a indicates that the velocity decreases. The average acceleration of the particle over the time interval delta t is defined as the quotient of the instantaneous acceleration a of the particle at the instant t is obtained from the average acceleration by choosing smaller and smaller values for delta t and delta v. The instantaneous acceleration will also be expressed in meter per second squared or foot per second squared. The limit of the quotient, which is by definition the derivative of v with respect to t, measures the. Applying the principle of rectilinear motion, let us consider a particle moving in a straight line, and assume that its position is defined by the equation x is equal to 6t squared minus t cubed, where t is expressed in seconds and x in meters, and the velocity v at any time t is obtained by differentiating x with respect to t. V is equals to dx divided by dt times 12t minus 3t squared. The acceleration a is obtained by differentiating again with respect to t. A is equals to dv divided by dt, equals to 12 minus 6t. Application of worded problems involving rectilinear motion. Such equations are for the